We will now discuss an important DNS attack named DNS spoofing/cache poisoning. You can use these words interchangeably. DNS, or domain name server, is a piece of software that translates human readable domain names such as google.com, facebook.com to IP addresses that are used to route communication over the internet. Normally, if the server doesn't know a requested translation, it will ask the next DNS server to do this translation for it, and so on and so forth. This is called recursiveness. To increase the performance, DNS servers usually cache these translations locally for a certain period of time before it expires. And this means the DNS server that caches these requests receive a similar request from a client. Next time, it will not go into the recursiveness or will not forward the request to the next DNS server, but will reply directly from the cache. So here is the vulnerability. When a DNS server receives a false translation of a domain name to IP, it will cache this false translation for optimization purposes, of course. And now we consider the DNS server as being poisoned. So it will supply the client with the wrong IP address, which is usually an attacker's IP address, and a different type of attack there will start. So let's go directly to our Kali machine here and do some examples. For this purpose, I have created a fake page on my local machine in which I will redirect the users to. It's under var www html, and if you list here, you will see the index. We'll open the index.html file, and you will see that I've created a very simple HTML page just with this sentence here: you have been hacked. So now whatever the user, our target client, will type on his browser, we will redirect him to this page. We will use the ethercap application again, but before going that, let's do a couple of things. We have to do some configuration here. Kate ether.conf, that's the ether.conf here. So I will copy it and we'll open it here. So before you start with this attack, make sure to change the UID and GID to 0. Default configuration starts with 65, so whatever number is here, just make sure that it is 0 so you can use this file. Next thing, we will as well locate the ether.dns file. Copy again this file, open it. Actually, this is the file that will have the fake DNS entry. So these are all commented entries. You can see this file, it has lots of translations. We're interested in these translations, so make sure to comment microsoft.com entries for the host name. Just make the pointer there without comment and add this here. So add a star, so any request that comes here, I'm creating a host entry and we redirect them to this IP, which is the local IP. And make sure to save the file and then close the file. Now open the ethercap application and then do sniffing on the interface, then go and scan for the hosts. Now we discovered these hosts, and here you go, these are the hosts available on the network. We are targeting this machine, which is the Windows 10 machine. So add it to the target and then go to the MITM and press on the R poisoning, sniff remote connections, and start. Next, we'll have to load the DNS spoofing plugin, and here you go. Everything now is up and running. If you go to the machine, Windows machine, and try to open the browser, just type here www.google.com, and here you go. The DNS has been spoofed and you have been redirected to my own page. Here another type of attack might kick in, like we will see these attacks in the web application section. You can create fake pages that similarly look like other famous pages, etc. So actually this kind of attack can be mitigated at the transport layer or application layer by performing end-to-end validation. A common example is to use TLS and digital signatures. For example, here if you open a page that have HTTPS, you will not be able to perform this kind of attack like Facebook. So this attack failed now because the user or the browser is checking whether the server's digital certificate is valid before establishing the connection. So this will not work. This will only work on websites that do not use encryption. In this video, I will discuss another type of attack on DNS called DNS zone transfer. It is actually a replication process between two servers, a master server and a slave server, in where the slave server requests a copy of the zone file from the master server, and depending on the configuration of the master server, a transfer might take place or not. Looking here at the screen, you can see that a zone transfer is configured to take place only to the following server with its IP address. A misconfiguration here might take place if you select any server. Thus, anyone requesting the zone file will be able to get it. Unfortunately, some companies, they misconfigure their internal and external DNS namespaces so that if this is misconfigured on this DNS server and you request a zone transfer, you'll be able to get a full map of the network. Thus, it's a very important piece of information to start with a network attack. The information that might be revealed from a DNS attack or DNS reconnaissance are these types of records. Start of authority, name server, any hosts configured on the DNS, canonical names, pointers, MX records, etc. So having this information is actually very important before starting any type of attack. So let's go directly to our Kali machine here and do a live example. I'll use a tool called DNS Recon, which is an advanced DNS enumeration script. It is written in Python and it's mainly used for DNS reconnaissance. It can enumerate DNS records, it can perform the zone transfer, and it can perform as well reverse lookups. You can invoke it by typing DNS Recon and you can type help. You'll be able to get all the help needed to invoke this script, such as the -n refers to invoking or mentioning the name server, R providing a range of IPs to do the reverse lookups, D is to provide a file with all the domains and subdomains of host names. What else? Another important parameter here is the A is to perform AX of R with standard elimination. Actually, it's to perform the zone transfer. AX of R stands for a query for zone transfer. Let's go directly to example here. Use DNS Recon and the -d parameter stands for domain. I'll use a domain called zone transfer.me and invoke it. So here you can see that it's performing the DNS reconnaissance. It gets all the information about the SOA record, the name servers, the MX records, all of this information, as well as this TXT record, which is actually mainly used to preserve the originality of sending emails and the privacy of your domain. Do a further example here by using the -a parameter, which is perform a zone transfer to the same domain. As you can see here, it will take some time, but actually you can see that zone transfer has been done successfully. Okay, it's over. So let's go back to the beginning of this script here. So now it revealed the SOA record, the name server record. So it actually revealed two name servers. What this script will do is actually to loop through these name servers and get all the records associated with the name server. So here it's trying name server, the first name server, and this is all the information associated. Going further, this is the second name server, and this is all information of the records as well. So, happy enumerating. Denial of service is actually a very simple attack that keeps the target system from operating as it should. In its very simple form, it uses up all the system's resources so that other people cannot connect legitimately and use this server. DDoS attacks are actually the easiest attacks that we'll learn in this course. It only takes a small little kit to install an application, put the target IP, and just press enter so that the attack will take place. The DDoS attack can be categorized under three headlines: volume-based attacks, protocol-based attacks, and application layer attacks. The volume-based attack is when the attacker sends a large volume of packets to the target machine, thereby using all the resources. Actually here we're consuming the bandwidth so we're filling the bandwidth. And these types of attack include ICMP and UDP floods. The protocol-based attacks is when the attacker utilizes all the resources of the target machine, and such attacks include Smurf attacks, Fraggle attacks, SYN floods, and ping of death. Here we are not utilizing the bandwidth, but rather utilizing the resources of the server. The third type of attack is the application layer attack, where legitimate application layer requests are being sent to web servers such as Microsoft IIS or Apache server with the intent to crash it. Now I'll show you how to perform a DOS attack from Kali. Of course, not DDoS attack, because it's actually the same type of attack, but DDoS involves more than one attack source. To do this DOS attack, you open a terminal and then you write, we will use the ettercap application again. Ettercap, then -G uppercase. It's the same way to open it from the menu, but here it's from the terminal. You go to sniff, unified sniffing, you press OK, and then you go to the plugins menu, manage the plugins, and you select DOS attack. You double click on this plugin, it will prompt you to enter the target IP. So we'll use our Windows machine here, local Windows machine, and then you enter the same IP again. And here you go, it's activating the DOS attack, starting the scan, and then starting the attack. So simply by using the ettercap application, you can launch a DOS attack.